So next up we have one of our product managers, Amit Pande, who oversees machine learning and is one of our core media PMs.
Thanks, Rick.
Thanks.
Let's see. So next we're going to talk about machine learning and how it is transforming the media industry. We'll first go through a few use cases and how people are applying machine learning. Then we'll talk about how Google can help you get started on that journey. We have an awesome demo. Hopefully we can get the laptop switched and make that working. And then we'll wrap up with a couple customer examples in terms of how people are applying machine learning. And then just after my talk, we have Naveed from Burst who's going to go in depth in terms of talking about how they are using machine learning inside their organization. So first, here's a very typical content lifecycle, all the way from creating your content to engaging with your audiences, to distributing it to a global audience, to being able to better monetize your content, to deriving new insights from your content to decide what content to create next, what content to license. Each of these steps, machine learning can help transform. We'll go through a couple examples in this presentation. So let's first look at content creation. So here's an example. Let's take the sub-step of video editing. Typically, for editing of the content itself, today what you'll have is you'll have a senior editor who will work with a junior editor who's going in and creating bins for different types of aspects of the content. For instance, in this particular case, they'll create a bin for close-up of food items. It was a food show. They'll create close-up of actors being able to find out where different set locations are. All of this is being done so that the process for the final editor, the senior editor, to create all of this content together is more seamless. Machine learning can help automate those steps. You can make it such that it is easy for the senior editor to quickly find those example shots. So for example, in this particular case, the user was looking for close-up of food items, and machine learning can automatically scan through your through your entire video reel and find those specific shots. Okay. Let's take another example. Today's users are used to consuming content at their own terms. They want to consume content in bite size. User A may want to consume a 3-minute highlight of last night's game. User B may want to consume a 5-minute highlight. With today's process, where if you have an editor cut the content manually, they have to do a fixed number of highlights, clips that they create for distributing to their end users. With machine learning, we can automatically generate highlights so that it becomes more seamless and users are able to consume content at their own terms. Machine learning can go in and automatically analyze every frame, every shot, your entire scene, and the entire video to find those relevant moments and help you create those highlights automatically. Take another example. Today you're starting to see more and more users put dynamic previews when you're browsing content. Again, those dynamic previews help with better engagement of content by the users. Correct? Like, there have been studies which have shown that you can have up to 2x higher engagement when you use automatic previews, and those previews are personalized to specific users. So again, to be able to do that at scale, it's just not possible using existing technologies. But with machine learning, it can automatically extract all of those right moments inside your video, generate those previews, help you serve and personalize those previews to your specific users. Let's switch gears and let's talk about engaging your audiences, both on the organic side as well as paid promotion side. Machine learning can help innovate and generate new techniques. So first, let's talk about organic. Content discovery, one of the core pillars for that is video search. Today, most of the video search systems which are out there, they index content metadata, so title, description, to some extent audio, which is going with the video, for you to be able to search your catalog. With machine learning, we can not only do all of those, but we can also index every frame, every scene, entire shots. So enabling your users to be able to do new experiences. For instance, being able to search for that final touchdown in a game, or finding that exact moment in a game, in a cooking game show, where the judges are giving out the final results. Correctly, being able to jump directly to the specific instance inside your content is a new kind of experience that both the end users are demanding for, and a lot of the content owners are now starting to use machine learning technologies for enabling those experiences. One of the challenges with this, for building this video search experience is being able to deal with things like custom vocabulary. And we'll talk about in later slides in terms of how some of the technology that we are bringing can help you with building out these custom vocabularies. Another example is recommendation, another core tenet of video discovery. Machine learning has been used for recommendation system for ages, but for the longest time, the only pieces of information that was being used was title, description, just all the metadata about the content itself. And with the advances of machine learning, there are things like being able to visually look inside the content and use that as another signal for building your recommendation system is an area that we're starting to see more innovation. And especially when you're thinking about kids' content, cartoons, and being able to look at visually similar signals is a lot stronger signal than just looking at the content metadata itself. Another example is, traditionally, you'll hear recommendation systems are only as good as the amount of data that goes into it, right? And really being able to combine data from multiple sources, whether it is data across your various business units, data across first-party and third-party data sets, data from your organization plus Google's data, correct? So that you can do all of that in a privacy-safe manner and then build this holistic model which can personalize end-user experiences is another area that we're seeing a lot of push and innovation in. Let's switch gears and let's talk about content distribution. In today's world, you're starting to distribute your content more globally. And as part of that, you have both challenges in terms of being able to reach those users and being able to do your distribution more efficiently. So we talked about in the earlier slide in terms of being able to use machine learning to automatically tag every frame, every scene, the entire video. We talked about machine learning can transcribe your audio. One of the key things I wanted to call out is with all of this rich metadata being generated, it's important to combine that with a simple edit tool like a UI-based tool where you can actually review all of the output of the machine learning systems. You can have operators go in and quickly fix any issues that exist with the output of your machine learning systems. And most importantly, let this both improve the current state of your metadata, but also feed this back as a feedback loop into your machine learning models, so that rest of your systems continue to perform well as well. Another example is folks are starting to use machine learning to automatically transcribe audio, translate that audio itself, and then more importantly, starting to look at the visual content to figure out which parts of the content may not be safe for work, or it's adult content, or also scenarios where they are looking to distribute the content globally, and there might be gun scenes or smoking scene, which may not be okay to distribute in certain parts of the world. So using machine learning to automatically find those specific instances, go and make the corrections inside the videos, that's another big area that we are starting to see advances in machine learning. And this problem, it first came to me, I looked at it and I said, is this one of the more critical problems or less important ones? And somebody corrected me by saying, as people are spending more and more amount of money in terms of producing original content, and the budget for creating content is in billions of dollars, the QC budget is also in hundreds of millions of dollars. So it was an eye-opener for me to see how much a large media organization is spending on just simple QC process, which is transcription, translation, making sure there is all the appropriate scenes are correctly tagged, whether for global distribution or whether it is adult or not adult content, plus basic QC operations like making sure audio matches video, audio is in sync with video. All of those steps, correct? Like people can spend tens of millions, maybe in hundreds of millions of dollars for doing that step itself. And this is sort of a byproduct of our ability to reach a global audience, correct? Like the budget of doing all these manual operations is also significantly increasing. I want to switch gears and talk about monetization. This is generally one of the top things on people's minds when they're thinking about the content. And machine learning can help significantly improve the monetization of your content. So here's an example. If you're monetizing your content using ads, ads shown at the right moment can perform significantly better as compared to regular ads. So let's take an example of a branded ad. When shown at the right moment in the content, it performs somewhere between 2 to 3 times better than a regular ad. Another example is if there is a commercial intent in the video itself, where maybe there is a shopping scene. Being able to accompany that with an experience where people can do a call to action, purchase the goods, the products which are being talked about in the content. Maybe it's visually similar, maybe it's a similar brand which is being talked about, same brand category or the same brand which is already being present in the content. All of these are new kind of experiences that media owners are bringing to their content to increase their overall monetization. Last but not least, when we think about video insights, I just wanted to share a data point. In 2013, Netflix had 3 pieces of data. It looked at cast, I think, director, and I think the genre of the content. And they used that to predict how well House of Cards will perform. And based on that, they greenlighted the show. The rest was history. 5 years later, the amount of data that is out there that can be used for making those decisions in terms of when you're thinking about what content to show, what content to license, correct, or create, correct, it's just amazing, correct? It's our ability to bring all of this content, all of this data together, analyze it, draw insights, and share that with folks who are making these decisions. So just to give you an example, machine learning can automatically understand the frames and the scenes and the entire video. In each of the frames and scenes, you can understand what is exactly happening in those scenes. Maybe it's a happy scene, maybe there is some action happening, correct? You understand which actors are there. You can combine all of this with your audience data to understand where the drop-offs are happening. You can figure out the screen time for a specific actor. You can figure out, do your audiences like more comedy or do they like more action scenes? And you can take all of the sentiment data, all the cast information data, and then use that for building prediction algorithms in terms of how well certain piece of content may perform. And again, it is trying to bring more data-driven feedback into the system. It's not replacing the art that exists in a lot of this work, but it's important to look at this data for you to be able to make more judicious decisions. So with that, I want to switch gear and talk about how Google can help you get started on this journey. So we have a full spectrum of tools. All the way, what you see on the left-hand side is a set of readily trained machine learning APIs for you to be able to use out of box. If you don't have machine learning expertise, that's a great place to start. We have APIs for understanding images, vision API, video intelligence API for understanding video. We have natural language API for understanding textual data, translate API for translating the data itself, like a full spectrum of APIs. All of this has been trained on massive amounts of Google data. So you pretty much leverage the power of Google's AI without having to really have a lot of deep expertise in machine learning. What you see on the right-hand side is a set of platforms and tools available if you want to build your own, right? All the way from we have TensorFlow, which is one of the most popular libraries for building your own neural networks. We have, on the infrastructure side, we have GPUs and TPUs. With Cloud TPUs, we just announced, which is our own custom silicon for training massive amounts of machine learning data, right? We just announced 3rd generation Cloud TPUs, which are significantly faster than the previous generation, which was already 20 to 30x faster than what you would see from a typical CPU versus GPU implementation. So when you're thinking about massive amounts of training data, correct, really leveraging the power of cloud, and more specifically Google Cloud, gives you that advantage where instead of taking weeks and months to train your models, you can get feedback in hours and minutes in many cases with the amount of data crunching capabilities these platforms have. There's also a whole slew of tools available, all the way from being able to use Keras, Torch, correct, any of the other machine learning libraries, as well as data science tools for cleaning up the data and prepping the data itself, right? So all of this is available today. You can get started with this today without any special permissions or access. Right? I want to briefly dig into two areas which I thought would be very relevant for this group. So the first one was Cloud Vision API. It helps you automatically out of the box detect faces, things like logos, being able to identify labels which are general descriptors of the scene. Maybe it's a scene about a dog, maybe it's an outdoor scene by the beach or by the water. It helps you recognize those. It helps detect any explicit content. It can also recognize any text that might be there inside of your images by doing OCR. It can recognize landmarks, things like Eiffel Tower or Empire State, but also things like web entities, which is, again, an area that I've seen a lot of media companies actually use the APIs for. We also have Cloud Video Intelligence API, which is basically taking a video as an input, and it automatically segments that into shots and attaches a descriptor to each of the shots. So there's about 20,000 labels already attached based on massive amounts of Google data. We automatically transcribe the audio. We can detect explicit content. We do face recognition, correct? And as you can start thinking about, as you think about these two slides, correct? These are the building blocks for you to build some of the experiences that we talked about earlier, right? You know what's happening in the scene. You know which people are present in the scenes. The scenes have already been segmented for you. You have the audio stream to which you can now apply natural language API to. You can do things like explicit content detection. If you combine all of this, this is massive amounts of rich data that you can extract from your content and use that to power your experiences for search, for recommendations, for paid marketing, or any other use cases that you come up with. So with that, I wanted to switch gears and go back to the slide. One of it, so till now, what I've talked about is these products have existed since 2017, very widely used. But one of the key feedbacks that we got from our customers is, hey, we love the APIs, we got started with it, I came up with a new use case or scenario. I'm sure you all have heard of it. I want to do X. My favorite example is there's a sitcom TV show and folks want to recognize a set location. So whether it's House of Cards and you want to understand if a scene is happening in the Oval Office or in Kevin Spacey's kitchen, or if it's Westworld, whether it is happening in the Mariposa Salon or it's happening in the command center, right? Well, that's custom vocabulary, correct? Like that is very specific to your content. And obviously we at Google don't understand that specific custom vocabulary, right? So how do we solve that problem, right? And so what we would do traditionally is we would point you to build your own model, right? Which is use TensorFlow, Cloud Machine Learning Engine, and start building models. And there were a few customers who were very successful. They worked closely with us and they started building their own models. But one of the challenges a lot of the customers were running into is, well, we don't have expertise for doing this work. There's tens of millions of app developers and web developers out there. There is probably less than 1 million data scientists out there who actually understand machine learning. Probably thousands who's deep machine learning experts, researchers. Correct? So when we talk about building this custom model, correct, you're really going after that pool of less than 1 million data scientists and maybe a few thousand researchers, in most cases media companies that really have access to them. And Google tried to help that with various programs that we have. We'll talk about that in a bit. But ultimately, we also have limited resources and we can only scale to this much demand. The second big problem was, this is not easy. Correct? Even if you have the expertise, correct? Like there are 3 big ways to manually label data, correct? This was another big problem. When we talk about machine learning and building custom models, you're talking about labeling data, having labeled data in tens of thousands, hundreds of thousands examples of each piece of label that you want to recognize, right? So the previous example that I shared about the set location, well, you have a one TV show, maybe 10 episodes in one season, right? A, you have zero label data. B, even if you decide to label data, you don't. I mean, it's 10 hours of TV content, correct? That you want to label and recognize. How do you solve that problem? Like it just doesn't work in terms of solving that problem. So to address that, we are coming out with new product, Cloud AutoML. This is specifically to address all of these concerns and challenges around being able to build custom models. We don't have enough data, we don't have the expertise, and we definitely need more than something beyond what the APIs are available. Right? And Cloud AutoML is really there to address this problem. What Cloud AutoML is doing is it's basically using machine learning to create machine learning models. Right? That's the core of it. And the underlying details are there are a set of architectures which have been published by researchers for being able to do that. One example is transfer learning. The other example is learning to learn, where we basically have a core set of a base machine learning model that has been fine-tuned and built by Google, and then you can retrain the final few layers of the machine learning model based on the specific use case. And you can use machine learning for you to be able to retrain those final few layers. Right? But at a very high level, what it's really doing is it's addressing that specific problem. It's like I don't have all of those experts, and I want to build a machine learning model. How do I do it? Right? So to use Cloud AutoML, you don't need machine learning expertise. You're building a custom model using your own data combined with Google's data. So we train the first many layers in the model using massive amounts of Google data, and it's just the final set of layer that you're training using your data. The other key piece of question that most folks have when they look at this is, what's happening with my data? Are you combining that with the rest of Google's data? And the answer is no. All of this sits in your project instance. You're getting access to Google's data to use as pre-trained models, and then you're doing the final layer of training using your specific data, and you're doing it inside your specific project. So Google has no access or no knowledge of what data you bring to that platform, what training you're doing, what models you're building. Right? All of this you can do through a fully managed UI. I'll show you a demo in a minute. But it makes it very simple. So if you're just looking to get started, you want to get a feel for the technology, correct? Previously, what you would have to do is learn about machine learning, spin up an instance with TensorFlow, correct? Brush up your skills on Python, correct? Like all of those steps, correct? Like are gone, correct? You can simply use a UI to drag and drop, get a feel for it, and then if you want to do more with it, you can always start hooking up with the rest of your code. And most importantly, you're leveraging the state-of-the-art performance of our model and quality. Right? You will see other companies since we've announced, have started to make attempts at doing something similar. That they lack the amount of massive data that Google has. The base algorithms were actually originally developed by Google, published as papers for folks to actually leverage. And more importantly, we continue to fine-tune those algorithms internally. So whatever you see out there in the open source world is a couple generations older as compared to what we're using in the real world. So the very first product that we've launched as part of this umbrella is the Cloud AutoML for Vision, specifically for understanding your vision, your image data, where you are able to build custom models. You'll see the same state-of-the-art performance as you would probably if you were to go down the process of building it using TensorFlow. Easy to use UI, I'll show that in a minute. Most importantly, what we've done is we've integrated this product with our Crowd Compute product so that you can leverage Crowd Compute for automatically labeling the data. And you'll see two folds. One is we've solved the problems in two ways. One is you don't actually need 100,000 examples for each label, which was one of the big challenges when we were starting from scratch. The other big problem was obviously getting somebody to label all of that data. So we are also doing the integration with a human labeling service so that it becomes very turnkey for you to be able to go through that. let's see. Okay. Even though the solution is for Cloud AutoML for vision, I want to briefly mention that this can also be applied for video content. Here's an example. What I did was I took the video content, used FFmpeg, sampled it at 1 frame per second, and then send it through the AutoML for vision and start generating those custom labels. And you can then use those use cases, use that custom label to power each of your use cases. So the example previously we talked about the set location, correct? Like take your content, send it through FFmpeg, sample it, and then we'll look at a few examples on how you can label the data, and then you can use that for powering. Say maybe you want to understand on your data analytics side how well a scene which has specific actor and that actor is present in a specific set location, how well that is performing, correct? You can quickly define that label. You can understand actors using our existing APIs for recognizing faces, and you can combine the two to build this query, right? Where you have this new label flowing all the way through your system into your data analytics or BI systems, right? Similarly, if you want to enable a new kind of a search experience, maybe for your internal CMS editors who want to quickly search through your library so that they can generate those clips. You can create this custom label, do a quick training of the model, save that as a query. And similarly, on the monetization side, maybe you come up with some use cases where you want to understand specific instances in your video, maybe with commercial intent, correct? And your video has got a lot of visual products in it, correct? And you use AutoML for vision for being able to recognize it. Right? So the key thing I wanted to call out is, even though the technology is available for images, you can extend that to video itself. Correct? So let's dive into the specific example. So on my flight, so unfortunately the example was done for some of the premium content, but since we're not allowed to show that premium content in a public forum, what I did was on my flight from SF, I just used some of my personal libraries, and I literally actually used some of the videos from some of my wedding videos to specify different set locations, correct? So there was a place where we were doing the dance, correct? There's a place where we were going through the formal walk, and then a place where the ceremony location was. And so we had like 6 or 7 cameras, and we're collecting all of that data. And I was like, wouldn't it be nice to be able to run queries like, identify a specific scene where I'm present and I'm maybe on the stage, correct? And I'm present. That's possible to do using existing APIs. But how do I really describe the dance location, the walk location, and the ceremony location? No public APIs are really going to give me that. So literally, what I did was took the video, sampled it at 1 frame per second, send it through FFmpeg, and then manually went in and tagged the images, fed it into AutoML, and on the other side, I was able to start using the API for doing the prediction. So that's the demo. Hopefully, I can switch the computers to show you the live UI. So what you see here is basically our UI for AutoML, right? And you can come into this UI. Basically, simply import your data set itself. Correct? You can import it using your have a CSV which has pointers to your images and labels. You could just arrange your content in appropriate label buckets, and then just upload it directly, zip it and upload it directly to the UI. Or you can just upload your raw content and use the UI for labeling. Then you can come in here, define your label. So I define the 3 labels: ceremony location, the dance party location, the walk location. And as you can see, correct, like I had about 40 or 50 examples for the first one, about 100 examples for the second one, and about 70 examples for the third one, correct? You can apply the labels to the images, correct? I have already done all the labeling, correct? You can use the human labeling service for manually going in and getting. You can come in and review. Basically, here's all the data. Here's all the data that I've uploaded, correct, for images, correct? And you can kind of let me flatten it out and show all the examples of the data which is out there. Right. I can go in and look at specific filters. So let me look at just look at the dance body location, right, to show you the example data that I had labeled. Right. And this is about 50, 60 images that's got labeled. Right. What you can see, the important thing, and I'll come back to the screen, correct? Like if you see, it's just bunch of images which has got me present. It's got the set location, but like some of the example images that we will pass in later on for prediction doesn't actually have me in it, correct? And the beauty of the technology is it's actually starting to understand like features like what's happening in terms of colors and shapes, correct, and the characteristics of the stage, correct, and using that for really understanding that other image that I'm uploading is actually from the same scene itself, right? So that's all the data, correct? You can basically go in and you can the UI train, correct, is literally as simple as hit train. I'm not going to hit train. It takes about 5 to 10 minutes in this particular case to train the model itself. You can come in and evaluate the performance of the model, correct? You can see how the confusion matrix, the confidence thresholds, and all of those are for the trained model itself. More importantly, literally use the UI for doing things like predictions, correct? And I will try and do a live prediction here, assuming nobody boots me off, correct? Let's see. I had a few test images that I saved from other parts of the video that I'm going to try and put it through. But I think the key thing, what I wanted to highlight as we look through some of these examples is even though the images are quite different from what was uploaded as part of training, the model itself was able to learn the characteristics of the images and be able to quickly classify them into each of the specific categories. And while that is coming, I think I have a saved version of it. Correct. So let's hope that actually works. Correct. But it's able to quickly understand all of those characteristics, and the way it is performing so well is the base model that was used for doing a lot of this training was trained on massive amounts of Google data. Right? So the problem that we talked about, large amounts of data that is needed, the way machine learning CNN algorithms say, all of this is using for understanding images is using convolutional neural networks, and the way it works is it uses the early stages of the model to understand the basic characteristics of the objects, and it uses the final stages of the model to understand the very specific shapes. Correct? Like you can actually, if you ever looked at the output of a CNN, you will actually see that in every stage. Is like what is it that the model is actually learning, and you see the final characteristics being learned in the very final stages of the model itself. So the reason Google's model is significantly better and differentiated, correct, is because we are training on that massive amounts of data. So here you can see the ceremony location. It actually recognizes it perfectly well with 99%, 100% accuracy. Correct? Here's the dance body location, correct? It recognized that with 99%. Just to give you a sense, correct, I think this is what we had open, correct? This is the training data. Looks quite different. Sorry, I think I should probably just filter it down to. Looks quite different, correct? Like it has some images which are slightly similar, correct? But nothing which is identical or even close to being identical to what you actually see in the image that I submitted into the model for it to learn. Correct? And the reason it is able to do that is all of that base characteristics. The other big win we are seeing with this is that problem statement that I started with, like how do you get a lot of examples, right? In this case, I only had like 40 or 50 examples per label, and the system was able to actually understand and start doing those predictions. So the problem statement that we started earlier in terms of massive amounts of data, custom vocabulary, doing your own training, and having machine learning experts for helping you with that. We're trying to solve that specific problem using AutoML. There's already a product available for understanding your images, and this was a quick example. Like if I can do, I'm not an engineer. And if I can do it on a flight from SF to New York, then I'm sure your researchers and the engineers will be able to do a lot more than what I'm able to do. Right? Like, just to give you a sense, right? Like we've had customers who will come and say, I want to detect that first black frame. And previously the answer was, you need to go build a custom model. You can easily do that with this. The example we were seeing earlier in terms of being able to detect close-up of food items. I built a custom model for building a close-up of whatever, right? Whether it's food item, people, right? Shot types. You can do that using AutoML. So a lot of these, are in many cases, even the researchers who build this technology are surprised in terms of the applications that people are coming up with for starting to use this technology. Cool. So I want to switch gear, briefly talk about, as you're thinking about getting started on this machine learning journey, we have a whole set of programs available out there, all the way from a bunch of training to get you started. There's training available on Coursera and others. There's also training available where if you want to do one-to-one training for your specific organization. We have immersion programs all the way from a couple days helping you identify the most impactful use cases to being able to do something like Advanced Solutions Lab where your team comes and sits side by side with Google experts to really build those complex machine learning models that will solve like high impact problems for you. But if I were to take one thing away from this talk, right, if you're just getting started on this journey of machine learning, I would probably start with looking at the APIs and see if that serves your use case. Look at creative ways of combining the vision, the video, the natural language, the translate APIs, and then look at AutoML potentially, and then look at potentially looking at building your own using TensorFlow, Cloud Machine Learning Engine. And if you need help as you're going through that process, work with our team, and we'll get you to life. I'm just going to quickly wrap up. There's a few examples out there of customers who are using our technology. Like Disney actually use the AutoML vision technology that I just showed for recognizing Disney characters. No surprise, right? They're out of the box. Google APIs don't really work well for Disney characters, but using the AutoML technology, it was working great. Box is using our Cloud Vision API for starting to understand the images and extracting all that metadata to power their search experience.